This simple circuit can turn your doorbell into a chirping bird. Hey guys! In this video, I'll show you how to make a bird sound doorbell using the 555 timer IC. Stay tuned to the second part of this video, where I'll explain how this circuit works. Here are all the components you need to set up this circuit. 2 alligator clips, 12 jumper wires, 1 2200 ohms resistor, 1 470 ohms resistor, 1 3300 ohms resistor, 1 100 ohms resistor, 1 5100 ohms resistor, 2 555 timer ICs, 1 10 microfarad capacitor, 1 0.1 microfarad capacitor, 1 47 microfarad capacitor, 1 1000 microfarad capacitor, 1 latch switch, 1 9-volt battery connector attached to a 9-volt battery as the power source, 1 5-watt speaker, a breadboard to connect everything together. The 555 timer IC comes with 8 pins. There is a notch or a dot on the chip's body. Pin 1, located at the top left, serves as the ground or ground supply. Pin 2, the trigger pin, initiates the timing interval in monostable and astable modes. Pin 3 serves as the output, providing the timer's operational result depending on its mode: monostable, astable, or bistable. Pin 4, the reset pin, is used to reset the 555 timer's internal flip-flop. Pin 5 serves as the control pin, enabling you to adjust the threshold voltage levels used by the internal comparators to set and reset the flip-flop. Pin 6, the threshold pin, monitors the voltage of the capacitor in the circuit. Pin 7, the discharge pin, manages the timing capacitor's charge and discharge cycle. Pin 8, known as VCC, supplies power to the IC. Let's set up the circuit step by step. Begin by positioning the 555 timer IC on the breadboard. The pins are numbered counterclockwise, starting from the top left corner. Refer to the later circuit diagram if you have questions about the circuit connections. Insert the 555 timer in the middle of the breadboard. Insert another 555 timer several rows below the first one. A jumper wire connects pin 8 or VCC to the positive rail. A jumper wire connects pin 1 or ground to the negative rail. Do the same steps on the second 555 timer. Use a jumper wire to connect pin 2 or trigger to pin 6 or threshold. Do the same step on the second 555. Use a jumper wire to connect pin 6 on the second IC to pin 5 on the first IC. Bend the ends of a 2200 ohms resistor. Insert the 2200 ohms resistor to pin 2 or trigger in pin 7 or discharge. Turn the breadboard to the side. Bend the ends of a 3300 ohms resistor. Insert the 3300 ohms resistor to pin 2 or trigger in the negative rail. Insert a 0.1 microfarad capacitor into pin 2 or trigger in the negative rail. Insert the shorter leg into the negative rail. Insert a 47 microfarad capacitor into pin 2 on the second IC and the negative rail. Insert the shorter leg into the negative rail. Turn the breadboard to the other side. Bend the ends of a 470 ohms resistor. Insert the 470 ohms resistor to pin 7 or discharge and the positive rail. Bend the ends of a 5100 ohms resistor. Insert the 5100 ohms resistor to pin 7 or discharge and the positive rail. Turn the breadboard to the vertical position. Bend the ends of a 100 ohms resistor. Insert the 100 ohms resistor to pin 2 or trigger in pin 7 or discharge. Insert a 1000 microfarad capacitor a few rows below the second IC. Insert the shorter leg on the left side. Use a jumper wire to connect the capacitor to the positive rail. Use a jumper wire to connect the capacitor to the negative rail. Place a latch switch in the center of the breadboard, a few rows below the capacitor. Use a jumper wire to connect the switch to the positive rail. Turn the breadboard to the side. Insert one leg of the 10 microfarad capacitor to pin 3, and the other leg a few rows below the IC. Insert the longer leg to pin 3. Insert a jumper wire in the same row as the capacitor. Insert a jumper wire to the positive rail. Turn the breadboard to the vertical position. Attach a red alligator clip to the jumper wire in the positive rail. Attach a black alligator clip to the jumper wire in the same row as the 10 microfarad capacitor. Attach the black alligator clip to the negative terminal of the 5-watt speaker. Attach the red alligator clip to the positive terminal. Connect the positive terminal of the 9-volt battery connector to the other leg of the latching switch. Connect the negative terminal to the negative rail. When you press the latching switch, you should hear the bird sound. Pretty cool, right? Every time someone knocks, they'll hear a friendly chirp instead of an annoying buzz. Let's dive into the circuit and break it down step by step. This circuit is a 555 timer-based bird sound generator. It consists of two 555 timer ICs working together to produce an oscillating sound when a latch switch is pressed. The circuit is powered by a 9-volt battery with a 1000 microfarad capacitor for power stabilization. The first 555 timer operates in a stable mode, generating a square wave signal. The frequency is determined by the 5100 ohms resistor, 100 ohms resistor, and 47 microfarad capacitor. When the latch switch is pressed, the first timer produces pulses that act as a control signal for the second 555 timer. The second 555 timer also runs in a stable mode, but at a much higher frequency to produce an audible sound. The 470 ohms and 2200 ohms resistor, along with the 0.1 microfarad capacitor, set the oscillation frequency. The output waveform from this second timer modulates the frequency of the bird sound. The final output is connected to a 10 microfarad capacitor and a speaker. The modulated signal creates a warbling effect, mimicking a bird chirping sound. The first 555 timer starts oscillating, sending pulses to the second 555 timer. These pulses change the frequency of the second timer, creating a varying tone. The second 555 timer outputs a square wave signal to the speaker. The modulation from the first timer alters the frequency, producing a chirping sound similar to a bird. The latch switch ensures the sound continues for a short time before stopping. I hope this video has shown you how to make a bird sound doorbell with a 555 timer IC. If you found this video helpful, give it a thumbs up, consider subscribing for more electronics tips and tutorials, and hit the bell icon to never miss an update. Thanks for watching, and I'll see you in the next video.